The middle ear has a lot of work to do. The middle ear is trying to connect the outer ear to the inner ear, where all the auditory processing goes on. The tympanic membrane is pushed by the sound wave, and in turn this vibration is passed on to the hammer. This is the first of the 3 small bones called the ossicles. The hammer pushes the anvil, the second little bone, which in turn pushes the final little bone called the stirrup. The stirrup in turn pushes what's called the oval window. These 3 bones, the hammer, anvil and the stirrup, are together known as the ossicles. They're the smallest bone in the body, and 3 of them can fit quite comfortably on a very small coin, like a US penny. The hammer and the anvil act effectively as a lever, amplifying the signal. Also, the oval window has an area of only 1/16 that of the tympanic membrane, and therefore we get an amplification of pressure associated with this as well. Impedance, sound transmission, and the middle ear. So when waves move from one medium to another, there is a lot of reflection when the resistance to the wave travel, and this is called the impedance, is high. If the impedance is high, therefore, transmission is less effective. What the middle ear is trying to do is transmit waves from the air of the outer ear into the fluid of the inner ear. So the goal of the complex middle ear bone structure is to avoid these impedance losses. The ossicles act to couple the 2 membranes together, of the tympanic membrane to the oval window, and they do this using mechanics, with the hammer being a lever. Let's look at this in more detail. The hammer acts as a lever arm to boost the force delivered to the oval window by about 1.5 times that of the tympanic membrane. You can see that in the diagrams here. There's a schematic showing the lever as the hammer. The fulcrum is associated with a ligament connecting the bone to the surrounding ear, and as the fulcrum is located approximately halfway up the lever, R1 equals 1.5 R2. Therefore, F2 equals approximately 1.5 times F1. The other amplification going on in the middle ear is the fact that there's a difference in the areas of the tympanic membrane compared to the oval window. A1, the area of the tympanic membrane, is 15 to 20 times that of A2, the area of the oval window. This also adds to the amplification. And in fact, what we can do is multiply these 2 together. So the ear provides 1.5 times the amplification from the mechanical lever system and 20 times from the change in the areas of the 2 membranes. So if we multiply this, we get about 30 times amplification. So the middle ear is a very effective amplifier. Indeed, there is no impedance loss in this system, as you would expect if we had a wave directly travelling from an air medium to a liquid medium.